Have you ever wanted to build an AI that can actually use your data, whether it's an internal knowledge base, customer support, or a talk to PDF app? They all have one thing in common: the ability to retrieve data from an external data source. And to do that, we need two things: an LLM and a vector database. So stick around, because by the end of this video, we'll have built a fully working talk to PDF app which uses OpenAI and Pinecone DB. During this tutorial, we're going to build a retrieval augmented chat interface. So a chat interface that has context of a document that we've provided to it. So in our case, we have this emperorpenguins.pdf that I've just downloaded. And the first line in the PDF is there are 17 species of penguins, all found in the southern hemisphere. So I want to be able to ask a question like how many penguins, just something really broad like that, and then have the AI answer that question based on the context of the document. So at the moment, no document is uploaded, and if I ask this question, it will of course say that it doesn't know the answer because it doesn't have any context on that. So if I then upload the PDF, wait for that to upload an index, and then now it's ready, if I ask the same question again, it should say that there's 17 penguins. There are 17 species of penguin, all found in the southern hemisphere. So this means that we've sent a message to ChatGPT, but it also now has context of the document that we provided to it. Now, the point of this tutorial is to focus purely on the retrieval augmented generation part. So we're going to just build the backend part out, and I've got a repository ready that has all of the front end code and the styling written for us, so we don't have to get distracted with any of that stuff. So if you do want to code along with me, then download the repository in the description, and then we'll start building out all of the backend components for this interface. Once you've downloaded the repository, you should be in the main branch, and then inside source, we have all of the front end components, so the text area that we type into, the chat interface itself, and then the upload component, and then some hooks that interact with our backend. So this use chat hook is actually sending messages to a backend API that should exist. If we look at the chat form, it should exist at API/chat. So we need to build two API routes, one to send chat messages to, and then one to upload documents to. Inside the upload component, we're sending a request to API upload. Inside our chat interface here, that's the upload component that's rendered here to upload a document. And then this component underneath is the chat component. So when we type a message in here and press send, that gets sent to API/chat. And then when we upload a document here, that gets sent to API/upload. We're using Next.js with the new app router. And to support API endpoints with the app router, we just need to create a folder inside app called API. So we'll do that now. Then we need two folders. First is chat, and then the second is upload. Inside both of these folders, we just need a file called root.ts, and then the same for upload as well. Now, before we start writing any code, we've got to install a few modules to actually work with these APIs and be able to parse PDFs as well. So let's type in npm i @pinecone/database/pinecone. So this is the Pinecone API for Node.js. And then we want the OpenAI SDK. And then we want two modules, PDF parse, and then the types for PDF parse, since we're using TypeScript in this tutorial. Let's just hit enter on that. And that should be all the modules we need for the tutorial. So we'll go ahead now and just implement the upload route. We import next response from next server. So this is just a TypeScript type. Then PDF from PDF parse. Then we'll import this chat service, which we haven't actually written yet, but we'll go back and do this in a second. Now we can define our first route for upload. Export async function post. And then the request is going to be of type request. Let's first define a try catch. And this is just a common pattern that Next recommend. So if there's an error, let's log it and then respond with that error. Return next response.json, failed to process message with the status code 500. And then inside the try block, we can actually implement the upload functionality. So the first thing we need to do is actually parse the form data. So we say const form data equals await request.form data. So from the front end, we'll be sending a form data request. Then we can grab the file from the form data. So we say file equals formdata.get file, and then set this as a file type for TypeScript. If there's not a file, let's return an error. So we return next response.json error, no file uploaded, and then the status code 400 for this. Then the next step is to actually process this file. Now the PDF parse library takes in a buffer. So we need to convert our file into a buffer first. We can do that by saying const buffer equals buffer from, and then inside that we pass await file.array buffer. We can then convert that PDF into text, saying const data equals await PDF, and then pass in the buffer. Then just grab the text from that data, text equals data.text. Then we can call our chat service, which we haven't written yet, but we would call chat service.indexDocument and then pass the text in. We await for that, and then it should return a chat ID that we can return back to the client. The chat ID just means that when we're sending messages in the future, the chat knows which document we want to talk to. Then let's just define a response. Const response equals an object with chat ID. And then finally, just return that response. Next response.json, and then pass the response in. Now, in a production environment, you'd definitely want to be uploading your files to something like S3 and then not upload into the server at all. Then just on the server side, we would download the file from S3 and then index the document to Pinecone that way. But in the case of this demo, just to keep it really simple and not have any more third-party dependencies, we're just uploading the document directly into our handler, parsing it in memory, and then providing it to our Pinecone database via the chat service, which we'll write in a second. But this still just demonstrates the flow that we need for retrieval augmented generation. So that's the upload component done. Let's now move on to the chat route. Here again, we want to import next response from next server. We import UUID v4 from the package UUID. So this was already installed when you pulled down the repo, and it just allows us to generate random IDs. And then again, we just import chat service from our chat service. Now let's define two TypeScript types, one for the request payload and then one for the response payload. The request payload will be called send message request. We'll accept a chat ID and a message. So the chat ID will tell us which document we want to talk to, and the message will just be the actual message from the user. We'll then define a response type, send message response. This will include an ID for the message itself, and then the content as a string, so this will just be the response from the LLM. We then define a new function again, export async function post, and then request. Again, we do a try catch block, log the error, and then return the error. Now this is just going to be a standard post request. So we just need to say body equals await request.json as, and then we'll cast that to our send message request payload. Again, in production, you probably want to validate this input with a package like Zod, but for now, we'll just assume that it's correct. So now we've got our body, and this should be equal to the send message request. So we'll have the chat ID and the message. We'll again call our chat service, await chat service.send message, and then we'll pass across the chat ID and the message. With the response from the chat service, which will be a string, we'll just return that to the client. Const response equals send message response. We'll pass in the ID using the UUID v4 package, pass in the content as well, and then finally send the response to the client. So those are the two routes now complete, and now we can implement the chat service. So we need to create a file at services/chat service. So inside source here, let's create a folder, services, and then chat service.ts. So we need to define an empty chat service that has the send message function, taking a chat ID and a message. And then inside upload, we will call in index document. So we need an index document function as well. And for that, we just passed in some text. So we take one argument, text as a string, and then let's export this. Now with this in place, the import errors from the other files should start to disappear. So now we can call chat service.sendMessage. Inside upload, we can now do chat service.indexDocument as well. So we just need to implement the body of these two functions. Now this file is going to be responsible for talking to both ChatGPT and our Pinecone database. So at the top, we need to import two packages, Pinecone from @pinecone-database/Pinecone, and then OpenAI from OpenAI. Let's create a new instance of Pinecone, passing across the API key, and then a new instance of OpenAI, again passing across the API key. So these two have pretty much identical APIs to initialize. Now I've already got my environment variable set, but you will need an environment variable for Pinecone DB and an environment variable for OpenAI. So make sure you go to the OpenAI websites and the Pinecone website to grab your API keys. For the Pinecone API key, you can go to pinecone.io, create a new project, and then under API keys, you can generate an API key. For the OpenAI API key, you can go to platform.openai.com/settings/organization/API keys, and then here, generate a new secret. Once you have the two API keys, make sure you store them in a .m file under Pinecone API key and OpenAI API key. And then with that in place, we should have full access to both APIs for the demo. Now we need to choose the embedding model that we want to use for this demo. So let's define a new variable called embedding model. And then this will equal, in our case, text embedding 3 small. So if you just Google OpenAI embedding models, the first result should be a list of all the embedding models available. And the new embedding models are this text embedding 3 small or text embedding 3 large. The cheaper one in this case is the small model. So we're just going to use this for now. In this document, it lists all the models that are available. So the previous recommended model was text embedding adder 002, but now we're just going to switch over to text embedding 3 small. And this is just the model that we will use to convert text into a vector that we can then send on to Pinecone DB to index our document inside a vector database. Now inside Pinecone DB, we'll have a project. In our case, I've just called it demo. And all of our vectors are going to go inside something called an index. So we need to first check if that index exists, and if it doesn't, create it. In our case, we'll just call it chat index, but you can call it anything you like. So let's create a function to fetch our index. Fetch index, it will take no arguments. Then we'll say our index is called chat index. Then the best way to check if an index exists, just do await pinecone.listIndexes. This will return to us an object with a key, indexes, and then we'll default that to an empty array. Then we just need to check this array to see if an index exists within it that has our index name, chat index. So we say if indexes.sum, and then we'll grab the index. We'll say if the index.name is equal to index name, then simply we can just return this index. So we say return pinecone index, and then pass in our index name. If the index doesn't exist, then we need to create it. Const index equals await pinecone.createIndex. We give it the name, index name, then the dimensions. Since we're using text embedding 3 small, the dimensions have to be 1536. That's actually documented on OpenAI as well. By default, the length of the embedding vector will be 1536 for text embedding 3 small, or 3072 for text embedding 3 large. So since we're using text embedding 3 small, we'll use the vector embeddings length of 1536. And the vectors that we store in Pinecone DB are literally just going to be an array of numbers. So there'll be an array of different floats. We might have like 1 point, blah, 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 0 point, and the array will be of length 1536. So when we request our embeddings from OpenAI, it will give us an array of the length 1536, which we will then pass to Pinecone to index that information. Now the final thing is just to pass in the spec. In our case, we'll run our database on serverless. The cloud will be AWS, and then the region, in my case, I'm using EU West 1, but you can use US East 1. I think if you have a free account, you might have to stick to US East 1. You might not be able to customize the region, but just try US East 1 to start, and then if you want to switch to a different region, you might have to upgrade your account. Let's just change this variable to new index. Then we can say below if not new index, and throw an error, failed to create index. And then if the index did create successfully, we'll just return pinecone.index and then pass our index name. Now with that in place, we try to return the index as is. If it doesn't exist, we create a brand new index and then just return that. Inside index document, we can now start to implement the functionality for this, so we can send our data on to Pinecone DB. So we've already passed our PDF to text, and now we just need to pass that on to Pinecone DB in the correct format. The first thing we want to do is create a new chat ID. So we say const chat ID equals UUID v4. Let's import this at the top. Import v4 as UUID v4 from the UUID package. Now to index the document into Pinecone, we don't just pass the entire block of text into Pinecone in one go. We actually want to chunk the text up into smaller blocks. And this is because when we search over the Pinecone database for a particular line of text, for example, how many penguins are there, we don't want to search the entire document, or we don't want to get results from the entire document. We just want to get results that are relevant to our search. So if we look at this PDF again, say if we were to split the document into blocks of 100, we might just index this paragraph, then this paragraph, and then this paragraph separately. So then when we go and search for a term like how many penguins are there, it's going to look over each of those chunks and then determine that this was the most relevant chunk because it tells us how many penguins there are. And then it would only return this from the vector database rather than all of this extra stuff as well. Then later on, if I was to send a search term that included like negative 1.9 degrees Celsius, it would more likely match on this particular block, so give us information related to this sentence instead. You could also ask it multiple questions, right? You could be asking a question that required context from this block and this block, which means later when we send a query to Pinecone, it would be able to return more than one relevant block. So we might get this paragraph coming back and this paragraph coming back. We can then supplement the message that we send onto OpenAI with these blocks of text and the user's question, and then we'd get a more relevant response from that service. So the first thing we want to do is chunk the text. So we'll say const chunks equals chunk text, passing across the text, then the size of each chunk. In this case, we'll have chunks of 1,000, and then we want a little bit of overlap as well. So this second argument to chunk text will be overlap. And again, looking at the Penguins PDF, overlap just means say as a single chunk, this paragraph plus a little bit of overlap. And then when we were chunking this paragraph, we'd have a little bit of overlap in the other direction. So say from here all the way down to say here. And the reason we have overlap is because if we were to return multiple chunks from our query and we needed sort of ongoing context between the two, the chat service would then know that these two paragraphs would be related because they'd have some common overlap data. And the common approach is to overlap by about 15 to 20%. So in our case, we'll just do 20%, have an overlap of 200 characters and then a chunk size of 1000 characters. Inside source, we can create a new folder called helpers and then a file here called chunk text.ts. Let's define a function, chunk text. We'll take in text as a string, the chunk size as a number, and then the overlap as a number as well. From here, we'll be returning an array of strings, and then let's just export default the chunk text function. We'll start by defining a new variable called chunks. We'll set that to an empty array, and then we can calculate the total chunks by saying total chunks is equal to math.ceil, the text length divided by the chunk size. So if we had a text length of 2000 characters and the chunk size was 1000, that would give us a total chunks of 2. So then we just need to loop over the total chunks. So we say for let I equals 0, I is less than total chunks, I plus plus. Then we need to calculate the start position. So start equals I times chunks. And then the end position, which is just going to be the start position plus the chunk size, start plus chunk size. Then this is just going to be the start and end without the overlap. So we now need to calculate with the overlap. So I'll say start with overlap is going to be start minus the overlap, and then end with overlap is going to be end plus the overlap. Then we just need to calculate the positions that we want to slice the text. So let's say start slice equals, if start with overlap is less than 0, we obviously can't slice less than 0, then just return 0. Otherwise, return start with overlap. And we're doing a similar thing for the end slice, but we don't want to go beyond the length of the text. Const end slice equals end with overlap. If it's more than the text.length, then just return the text.length. Otherwise, return end with overlap. Then we can create our individual chunk. So we say const chunk equals text.slice. Then we pass in the start slice, the end slice, and then finally push that to our chunks array. Chunks.push chunk, and then return the chunks. Now jumping back into chat service, we can import our chunk text helper. That's coming from helpers chunk text. So now we've got the text chunked, we need to convert each chunk to an embedding that we can then pass on to Pinecone DB. So let's define an array of arguments we'll pass on to Pinecone DB. So I'll say index requests is just equal to an empty array for now. And in fact, let's add a type for this. We'll call it index document request. And then at the top of the file here, so to Pinecone DB, for each chunk, we need to provide an ID, some metadata, the values, which will be the embeddings themselves. So these are the actual vectors that are stored in the vector database. Then we need some metadata, and the metadata will be the chunk of text itself. And then let's pass in the chat ID as well. And we pass in the chat ID so that later when we're querying the database, we can filter by our specific chat ID. And that means we'll only get results related to our specific chat and not other chats. So if we've got multiple chats open and each has a different document in it, we can get results for just a single document. So go back down to index document. Let's do another for loop. Let I is equal to 0, I is less than chunks.length, I plus plus. Then we'll grab the first chunk. Chunk equals chunk size, and we're using a standard for loop because we need the index in our case. Now for each chunk that we get, we need to convert that chunk into some embeddings, and we use OpenAI to do that. So const response equals await OpenAI dot embeddings dot create. Into this we'll give the input, which will be our chunk of text itself, then the model, and then we can pass in the variable we created earlier, embedding model, which will be equal to text embedding 3 small. Then we can push a new value to index requests. Index requests.push. Then we'll just need a unique ID for each chunk. So let's say chunk and then give it I. And then we pass across our metadata, which should be the text, which is equal to the chunk of text. Then we said chat ID. And then finally we need to pass across the values. And the values will be at res data 0 dot embeddings. So with that in place, we should now have index requests populated with all of the requests that we can send on to Pinecone DB. And we can do that in a single upsert. So first, let's grab our index, Pinecone index equals await fetch index. And then we call await Pinecone index dot upsert. And then we pass in our requests. And then finally, from this, we can just return the chat ID. So this is the complete flow needed to index documents into our vector database. First, we pass in the text. We chunk the text into smaller blocks. Then for each chunk, we create a new embedding. We create an object with a unique ID The metadata will be the chunk of text itself and the chat ID, and then the values will equal the embedding for that particular chunk that we grabbed from OpenAI. We then have an array of all of these objects, which we pass to Pinecone DB via the upsert method. The final thing to do now is to implement the send message method. So in here, we're going to get the chat ID and the message from the user. And the first thing we want to do is convert this message to embeddings. So convert this to an embedding in the exact same way that we converted each chunk to an embedding. We'll say const embedding response is equal to await OpenAI. Again, embeddings, again, create. The input this time will be the user's message, and then the model will be the same model. It's super important that you use the same model to convert the user's message to an embedding as you did to convert each chunk to an embedding. If you use a different model, the search just won't work. Then again, we need to grab our Pinecone index. Pinecone index equals await, fetch index. Now we can query the Pinecone database with the embeddings from the user message. Const query response equals Pinecone index.query. Then the first argument we need to pass in is vector. So these are the vector embeddings that we want to search with. In this case, it's going to be the embedding response.data0.embedding. Top K, we'll set this to 5. So this just means how many chunks to return. So in our case, we'll just return 5 chunks. Include metadata, super important, set that to true. We're going to need this in a second. And then filter will be our chat ID, and then $ equals the chat ID, or let's pass in the string unknown. And this just means that if we've got multiple chats or multiple documents indexed into our database, we're only going to return the document relevant to our particular chat. Now with the user's message and the query response, we can pass on a message to OpenAI that includes the user's message, then augment that with the data from Pinecone itself. So this is where the term retrieval augmented generation comes in. So let's define our prompt, set that as a template string. Then the first thing we want to do is preload our prompt with some information. So in our case, we're just going to say, you are a helpful assistant, please answer the following question. Now, of course, you could put any prompt here to give your service a personality or guide it into giving responses in a certain format. Then we pass in the user's message. So this will be a message like, how many penguins are there? Then we supplement the message with the information from Pinecone DB. So we say, here are the relevant chunks of information with their scores. Please prioritize results with higher scores when answering the question. So the response from Pinecone DB will include the metadata plus a score based on how accurate that result is to our search term. So here we can say query response dot matches dot map, and then from here we'll get each match, and then let's return another template string. And I always find it really useful to define this kind of stuff as XML, because it's really easy to like structure it and supply extra attributes, like in this case the score. So we'll say chunk and then chunk again. For each chunk, we'll provide the match.metadata.text, and then we can also supply the score here as well. So score equals match.score. So I hit save on that, and then we can just send this prompt on to ChatGPT. Const response equals await OpenAI.chat.completions.create. The model we want for this, let's just choose GPT-4o mini. Then we can send on all the messages. So let's send an array of messages. In this case, we'll send a message with a role of user, and then the content will be the prompt. From here, we'll return responses.choices0.message content. So this will just be the actual text response from the model. Now you'll notice that the types are a little bit incorrect here because we've got match.me and it doesn't have the value text on it. This is just equal to undefined. So we need to use our type index document request to add some type support to our Pinecone index. So here, when we say pinecone.index, we can actually pass a generic value in, which should be equal to the metadata value. So here I pass in the index document request metadata. And again, we can copy this and then use it again down here. Let's just add some no-null assertions here as well and here. And then now, match metadata should equal text or chat ID. That means that when we're getting values out of metadata or passing values into metadata, like here, it has to match our particular format. If for some reason there's no response from OpenAI, let's just return a backup message. Sorry, I can't help, just in this case. So let's just log the actual prompt that we're sending on to ChatGPT. Console.log prompt. I'll make this a little bit bigger. And then let's say this again, how many penguins? So we get a response from the service, and then this is the message that we've actually ended up sending to the model. So we say, you are a helpful assistant, please answer the following question, how many penguins? And then we have the text that we typed in. Here are the relevant chunks. And then we have XML tags with each chunk, and each of those chunks has a score. So you can see that the first chunk that we find has the paragraph. There are 17 species of penguins. And then we have a bunch of other chunks that maybe are less relevant, and we provide all of this to the service. So then we just offload it to the AI, and then it can just respond with the context and the user's question, and then hopefully give us a smart response back. So that was everything you need to build a talk-to-document app with OpenAI and Pinecone DB. You can grab the link for the source code in the description, and if you like this kind of content, then please give the video a thumbs up and subscribe, and I'll see you guys in the next one.